let me take you into a bit of the discussion around what we've begun to term the world of cognitive networking, okay? And I want to deal with kind of a misconception up front and a fear. This is not man versus machine, right? This is man and machine. You know, my role, I'm part of IBM's global telco industry. My role is to help bring together the world of the cloud and the world of cognitive and deliver that through the lens of the industry. And for this area here, my focus is on the world of strategy and business development for network and OSS transformation. And we're in the middle of doing this with clients. This is not something that's coming in the future. This is a taste of what we're doing today with clients and what we've been doing for the last couple of years with clients around this space of taking the world of AI and automation and applying it to this world of operation, applying it to the world of the network that exists today, and this world of the virtualized network as well. So let me take you forward. First of all, the disclaimers, right? Got to have that. But this is kind of where we're at, if you think about it. And this is not to minimize anything that anybody has done. I'm not making a joke of that. But in many ways, we are viewed from the outside as we have just begun. There are many of us that have worked very hard to implement, virtualized service, a service in a silo, but it's kind of like a standalone appliance. And as we now bring that into the world of the business is looking at us saying, okay, how do I operationalize this? How do I get beyond day zero of deploying this and beginning to use it? Because now when the software upgrades come out, now as the problem tickets begin to come in, how do I begin to deal with that? Because the paradox we're dealing with in the world of NFV is, Glenn put up the chart at the beginning trying to be humorous, right? It becomes much simpler, it's much easier, it's wonderful. The problem is, we've got our level 3 techs handling problem calls on day one that we should have our level 1 guys just solving. That's not gonna be very effective. Remember, we sold this to the business 5 years ago. We came in and said, this is going to radically reduce cost. And yet what has happened is it's increased the complexity, increased the operational cost. And now we got to figure out, how do we take that out of here? All right? And so this whole discussion begins to become, how do I take cost out? Oh, by the way, and keep increasing the innovation speed that's going on. And we're getting taste of that, but what I want to show you is what we're beginning to work with is to say, how do I take the world of AI and the world of automation and begin to apply that into this world of operations? Operations today, physical world, operation tomorrow, hybrid world, okay? Virtual and physical. How do I apply that into the lifecycle management as well? Okay, and I'm going to give you some taste of what we're doing here as we begin to do that, because it's really quite an interesting environment here that we begin to work through. Let me give you a taste here. First of all, in the world of AI and automation applied to the world of operations, what we're finding is if we can take it, we can begin to simplify the environment, we begin to drive predictions with the machine. We don't have to have an army of data scientists working this thing out, right? We can use the machine to really predict, to get ahead, and then we can begin to augment the process. And this one's the most fascinating one to me, because now we're beginning to really take cost out of the environment of operations. And then the last one is, okay, when all else fails, and I hand it over to that level 1 tech, how do I augment that tech person to be as good as my best? That's what we're working through. So let me give you a taste on some of these, okay, because I gotta be cognizant of time here. First of all, to simplify and focus, what we're using is the power of analytics, the power of AI, the power of the machine to go in and begin to reduce down the number of events. We're getting millions of events now. The problem with being able to do things at software speed is I can get problems at software speed. How do I reduce all of those? I've got to begin to use AI and analytics, converge that down to the few, the simpler. And then I've got to be able to use those AI and analytics to begin to focus on what's really driving value for my business, not just what the most immediate problem is. And if I can do that, now I can begin to focus on the 15 to 20% of the problems that are really coming in. Now I can really focus in on within that 20%, I can begin to focus down into those that really drive value for my key clients and for my business. And as I do that, one of the things we're finding is the need to be able to take this world of AI and analytics and begin to drive real-time topology. Topology that I know what exists and where it exists across both the physical and the virtual environment, and be able to present that to my operations team in real time of what they're looking at now. The problem is, typically by the time my operations team is looking at a problem, the event's already at least 5 to 10 minutes old. What did the network look like at the time of the event? And so can we do, this sounds like CSI, right? Forensics on the network. Can I actually go back in time and take a look at what the state of the network was, physical, virtual? What was it like before the problem, after a problem, during the problem? Can I actually see what the network looked like? And yes, we're actually using this world of AI and automation to bring that to reality now with a real-time topology so we can see that and be able to act upon that. And it becomes really important as we move now into the world of lifecycle management. So this is kind of like step one. Step two is, can I use the power of the machine to do the predictions? We always think about setting threshold levels and things like that with really smart people that know the network. My problem is I don't have an army of those people working 24 hours over the weekends, and every time my network changes, I can't have them go back through and find all the correlations. But can I use the machine to do that? And we've actually taken the Watson algorithms that, the world that we so favorably call in IBM the world of Watson. We've actually taken some of the Watson algorithms and applied them to all of the KPIs that our clients have. And we don't say, give us the top 10, don't limit the data, give us the entire list of all your KPIs, KQIs, and let Watson find the similarities, right? Let these algorithms find the similarities between them, and then let them look for the abnormalities to those. And we're beginning to find, we can find the problems anywhere from an hour to 2 days ahead of time, problems that people didn't know existed, problems that people did know exist, but they were setting thresholds and didn't know about it until the problem was occurring. Right? This is the power of the machine now applied to automation. So now that I've simplified it, I've started to get ahead of it. The next piece that we're finding in this puzzle is to really move to augmenting the operational process. And this is interesting. When we call in for things, whether it's our HR department or our health insurance or something like that, we're actually running now, many times, you and I, as we make those phone calls, we're running through a robotic-enabled process. And we've enabled this robotic-enabled process in the world of telco with customer care a lot of times. Guess what? We can apply that to the world of the network and the operations. And so the idea here, and I love this picture. When somebody showed me this picture the first time, I said, that's not a good network operating system. There's no one there. And somebody said, that's exactly it. We want the machine to be doing this. And so can I take those problems now that I've solved down to the most important, and can I hand that over to the machine and have the machine handle 80% of those? And when the machine has a problem and it's executing the script that I've given it through robotics, can I have it then call out to my machine learning and say, what's the best next step at this point? What should I do? I don't know what to do next. And then we actually have Watson answering the question back, just like we do when we're calling into HR and finance, or we're calling into customer care these days. We have it answering back and saying, go check this, go do this, go reset this device. And then the robotics take off and answer all that. Now what I've just done is I've simplified that down to an even smaller amount of things. The problem is now I'm handling over the most difficult problems that the machine can't solve to my level 1 tech. And so the question is, how can I augment their intelligence? How can I go through and pull together all the structured data, all that analytics that we got in the big data lake? How can I go get all that unstructured data? All my problem records, all my best practices, methods and procedures, how can I bring that to bear for just what they need at that point in time? I've got one client that went through and began to do this just with vendor manuals. What they did is they ingested the vendor manuals. Okay, that's a pretty interesting thing. Unstructured environment to very structured data, be able to pull that information together. They have begun to solve problems 60% faster. Think of that. If you could take your staff and begin to have them solve problems 60% faster, would that be worth it? Yeah, right? And so now, if I can bring more information together, the trouble tickets, the change requests, all that information to bear for that person, they can begin to solve that problem faster. And oh, by the way, remember how I was talking about the process calling out to Watson and asking a question? What if I can enable, we all have that smart chatbot stuff we're implementing for our customers. What if I implement that for my field staff, for my own organization internally, operationally? And I begin to interact then with this world of Watson, answering the questions back and forth. Help me understand this. I don't understand what that term is. What do I do in this situation? And we begin to get two things there. One, we get the problem solved faster. Second, though, is now I have a record of how a problem is solved. I can take that as a piece of intellectual property. Remember, this is unique for each carrier because every carrier is different. I can take that information now and ingest it into the process piece I was just talking about and have the process be a learning process there. So you begin to see this all come together. And we can give you a taste of this. This is what we've been doing for the last couple of years. This is what we've been doing for clients, doing it for the fulfillment side, moving it now into the assurance side. It's really kind of an exciting place. The next place, though, is the world of AI and automation. Applying to this world of lifecycle management, let me give you some tastes here. Right? What we're finding is we have to really approach it from an end-to-end focus and then drive something I really want to focus on, a machine-enabled automation. All right? Then we go into this world of the service factory. And it's not just that it's a service factory and we're doing DevOps and it's going faster and we're able to bring services to bear. I am automating end-to-end the service enablement factory. That's what it's about. And then the last piece is I have to be open. I have to be ingesting open. I have to be using open. And I have to be opening up all the things that I'm doing, right? So that's what we're talking about as we go through this. Let me hit on this a little bit first. End-to-end. End-to-end occurs in kind of three layers of the discussion. First layer is the world of operations that we just talked about. The second piece, though, is I've really got to think about the end-to-end service flow from the point of order all the way through initiation of that, all the way to the termination of that service at some point in the end of the life. The third piece is a piece that Diego just touched on, is this, he began to get into this discussion about Hyperledger. There is a business process surrounding my world of operations as well. And I've got to begin to think about this from end-to-end perspective as well. How can I enable that with a software-enabled supply chain of all my vendors to be able to enable this space? And that's this world of the Hyperledger down at the bottom. And so whichever piece you want to start working on, the operations piece, the lifecycle piece, or this Hyperledger piece, those are areas now that you got to begin to think end to end, and you can begin to bring that to bear. And we can show you examples of those. This one, though, to me is fundamental. We talk a lot about intent engines, okay? And yes, we need an intent-based engine. I need to know where I am. Remember the discussion of the real-time topology. I need to know where I am and where I need to go. But instead of me, this was the problem that we were dealing with when we started dealing with this discussion. A client came to us and said, hey, I automated my ability to do one step of my life cycle. It took me 5,000 lines of script for one transition in the life cycle. And we said, oh no, that's a problem, especially when you want to develop hundreds of services. You want to do it with multiple vendors, right? And all of a sudden you're into a world of script writing. One part of my IBM company said, hey, this is a software DevOps problem. We can solve that with our DevOps tooling. I'm going, we'll never solve it that way. It's going to become, every telco will become a massive DevOps software shop. That can't, how can we begin to get the machine to automate? How can I get the machine to think about what are the steps, assemble those steps and put those together? Think about this like your satellite navigation system in your car, Google Maps. Google Maps has standardized the steps of travel from point A, where you are, to where you need to be. I have an intent engine. I know I want to go downtown to the Firehouse Brew Pub tonight, okay? I did that last night. Anyway, but in that step, right, all of a sudden I say, I know where I am, I know where I want to be, and Google Maps assembles the steps. Right turn, left, merge left, merge right, go so many miles straight. Can I do that with the process of the life cycle? And then can I have the machine form an opinion, machine learning, an opinion of what the pattern needs to be to go from step A, where I am, to where I need to be, based upon the traffic, the weather, construction? Can I do that with my network? And the answer is yes. Because what we've done is we've built that intent-based engine to be able to enable that kind of machine-enabled automation. So I'm not now writing these thousands of lines of script and nesting those thousands of lines of script inside of other lines of codes of script. This piece itself, to me, is one of the areas that I think is fundamentally different about the approach to automation here. If I can get the machine to help me not write all those lines of script, but to assemble those together in real time based upon the real-time topology, using that kind of intent-based engine, not at just the fabric level like we've been talking about many times, but at the layer of the service end-to-end. And so that becomes really exciting too. Automating the service factory, this means that I can't just think about it from, Jill's side over here. I got to think about it from Jack's side over here. I got to bring my engineering and operations teams together to do this. because it's a continual engineering, continuous improvement environment that I've got to drive. That's what we're about here. Now, I've got to automate that end to end. I've got to be able to rapidly scale, roll out 10,000 servers, test out this new level of code that I just got in for one of the 10 VNFs that make up this service, test that out, destroy that environment, and roll that through my production environment so that I can now get the next level of code out, or the fix that the operations side has just determined that they have. It's got to be used by both sides, and so that's why we're looking at this is how do I enable a factory environment for the service lifecycle delivery, and how do I automate that in a highly automated way? Last thing is this idea of open enablement. As we do this, we consume open source, we build it with open source, and then we expose those things that are unique. We expose that also through an open source project. And this is a way that IBM's been doing this for a while. We literally have 200 of these projects going on right now, and they end up getting what we try to do is get them adopted then into the different open source outfits, because we realize this is a critical piece of what we need to be able to do. So I apologize. I know sometimes I do talk fast, and if you're listening to this in a second language, I apologize that I talk so fast, but there's a lot of time here that I've got to move through. But why IBM? What's really interesting is we don't have a VNF in this game. But we do understand the world of cloud, and we're bringing that together with the world of the network and this world of automation, and we're applying the knowledge that we have in AI to this. And if you want a taste of that, we've got some taste in there for you to take a look at. But you see how we're beginning to take a look at this problem in sync with what the Zero Touch team is doing, in sync with what was going on in the world of NFV, but in terms of using some of these deep competencies that we've got as well. So thank you very much, and if you have questions, I'll be out back later. Thank you.